Now we are going to discuss the Laplace transform of periodic function. Let f of x be any function. It is an arbitrary function. We have already studied what we mean by a function. Now let us start with an arbitrary function f of x. Now this function may repeat its values or it may not repeat its values. Suppose you have a function like this. It is not going to repeat its values as x changes its values. So y equal to f of x. So there are some functions which repeats its values in a regular interval and other function may not repeat the values. For example, if you take f of x equal to sin x, then the graph of that function looks like this. That means in every interval of length 2 pi, the function is going to repeat its values. So any function which repeats its values in a regular interval is called a periodic function. So here sin x is a periodic function, cos x periodic function. If you take an example of your daily life, the day of a week, suppose you have Sunday, every 7 days it is going to repeat. So Sunday is periodic with period 7. Your semester end examination, that is periodic with period 7. And month of an year, that is also periodic with the period 12. So mathematically, to say that this function is periodic, it has to satisfy the condition there exists. This symbol is for there exists. There exists a non-negative number t such that f of x equal to f of x plus t. So any function satisfying this condition is called a periodic function. So in a simple words, any function which is going to repeat its values in a regular interval is called periodic function. So this is about the definition of a periodic function. So what is the advantage of a periodic function connected to Laplace transforms? Suppose I have this function y equal to f of x. Now finding the Laplace transform of this function, I had to think of x varying from 0 to infinity. I had to think over that infinite interval. Suppose you have a function that is periodic. Suppose I have this periodic function sin x. Suppose you have f of t equal to sin t. Then to find the Laplace transform of this, it is enough if I find the Laplace transform over this interval. Then we can do some use multiplication or other simplification to find or to extend the Laplace transform of the whole function or Laplace transform on whole interval. So the theorem that helps to find the Laplace transform of a periodic function is, if f of x is periodic, f of x is periodic in the sense it has to satisfy the condition f of x equal to f of x plus t, then the Laplace transform of f of t equal to, as I said, it is not necessary to go from 0 to infinity. It is enough if I go from 0 to t. So integral 0 to t e power minus st f of t dt. And this gives the Laplace transform of the function over this interval. But I want a Laplace transform of the function over the given interval, which may have infinite length or a finite length. So this should be multiplied by a multiplying factor 1 divided by 1 minus e power minus s into t. So this is the formula that helps to find the Laplace transform of the periodic function. Now based on this formula, we are going to solve some problems. So problems. First one, find L of f of t. Find L of f of t if f of t equal to t square 0 less than or equal to t less than or equal to 2 and f of t plus 2 equal to f of t. So this is the function. We have to find the Laplace transform of this function. Now look into this. Here it is given that f of t equal to t square, when t lies between 0 and 2, and then it is satisfying the condition f of t plus 2 equal to f of t. Now compare this with this one. Solution. So given f of t equal to t square if 0 less than or equal to t less than or equal to 2, and not necessary to write this. Instead of that, comparing these two, you should get the value of capital T. So capital T is 2 here. Now I have the function and I have its period. Now I need to find the Laplace transform of this function using this formula. These two data are enough to find the Laplace transform. I want to get what is t, then I want to know what is f of t. If that is obtained or that input is given, then finding its Laplace transform is not difficult. Now we have, I'll recall this formula. Laplace transform of f of t equal to 1 divided by 1 minus e power minus s into capital T into integral 0 to capital T e power minus st f of t dt. Since this formula involves both capital T and small t, whenever I pronounce this, I will say as capital T. If I simply say t, that refers to small t. Now I have this formula. To apply this formula, I want to first substitute the value of capital T, then simplify the expression. First substitute for capital T only. So substituting for capital T, I will get f of s, the left hand side, f of s equal to 1 divided by 1 minus e power minus 2s into integral 0 to 2 e power minus st into, here f of t is t square dt. Now I got this expression. Now evaluating this, I will get the Laplace transform of f of t. Now this I will keep as it is, no change in that term. So 1 divided by 1 minus e power minus 2s into integral 0 to 2 e power minus st t square dt. To evaluate this, I should treat t square as first function, e power minus st as the second function, then apply integration by parts or Bernoulli's rule of integration. So applying Bernoulli's rule of integration, I will get first function t square into integral of e power minus st. E power minus st divided by minus s, e power minus st divided by derivative of that inner function minus derivative of t square 2t into integral of e power minus st divided by minus s, e power minus st divided by minus s into one more minus s, you get plus s square. Plus, I should write alternative sign, so it is plus derivative of 2t, that is 2 into integral of e power minus st divided by s square, e power minus st divided by minus s cube between the limits 0 and 2. So that is the integral of this one. Now 1 divided by 1 minus e power minus 2s. To apply integration, to apply these limits, so I will write these terms as minus 1 by s times t square e power minus st between 0 and 2 minus 2 by s square times t e power minus st between 0 and 2 minus 2 by s cube times e power minus st 0 and 2. Now applying these limits, what we get? So 1 divided by 1 minus e power minus 2s times minus 1 by s into t square e power minus st hat. So 2 square, that is 4 e power minus 2s minus 0 into e power 0, you get 0. Minus 2 by s square times 2 e power minus 2s minus 0 into e power 0, that is 0. Minus 2 by s cube times e power minus 2s minus 1 s e power minus 2s minus e power 0, that is 1. So f of s equal to, therefore f of s equal to 1 divided by 1 minus e power minus 2s times 4 e power minus 2s divided by s negative times minus 2 into 2 get 4 divided by a square e power minus 2s minus 2 by s cube into e power minus 2s minus into minus plus 2 by s cube. So this is the Laplace transform of the given function f of t equal to t square. So next let us consider one more problem. Find the Laplace transform of f of t where f of t equal to problem P. Find L of f of t. F of t equal to where f of t equal to t if 0 less than or equal to t less than or equal to a, and 2a minus t if a less than or equal to t less than or equal to 2a, and given that f of t plus 2a equal to f of a. So this is the given function. We need to find its Laplace transform. So as usual, compare this with f of x plus t equal to f of x, then identify what is capital T, the period of the given function. So identifying that, we can apply the formula easily. Solution given f of t equal to t if 0 less than or equal to t less than or equal to a, and 2a minus t if a less than or equal to t less than or equal to 2a. Now I have a periodic function. Now I need to find its Laplace transform. Observing or comparing f of t plus 2a equal to f of a with f of x plus t equal to f of x, this is f of t. F of x, we get t equal to 2a. That is f of t plus 2a equal to f of t. So I got t equal to 2a. So by applying the formula, I have Laplace transform of f of t equal to 1 divided by 1 minus e power minus s into capital T into integral 0 to capital T e power minus st f of t dt. So this is the formula to find the Laplace transform of f of t. Now substituting for t, I will get 1 divided by 1 minus e power minus 2as into integral 0 to 2a e power minus st f of t dt. Since the function is defined in two subintervals, we can't substitute for f of t directly. So in the first step, substitute for capital T only. Then substitute for f of t looking into the given interval. Now 1 divided by 1 minus e power minus 2as. Here the function is defined in two intervals. When t lies between 0 and a, it has value t, and when t lies between a and 2a, it has value 2a minus t. So according to that, I have to split this integral. So it will be from 0 to a e power minus st dt plus the second interval a to 2a e power minus st dt. Now in the first interval, when t lies between 0 and a, the value of f of t is t. So here I should write t. And when t lies between a and 2a, the value of the function is 2a minus t. Now applying integration by parts, this will be, I'll write from here, f of s is equal to 1 divided by 1 minus e power minus 2as times, here I have to treat t as first function, e power minus st as the second function. So first function t into e to the power of second function, e power minus st divided by minus s, minus derivative of first function 1 into e power minus st divided by s square between the limits 0 and e, plus here I should treat 2a minus t as the first function and e power minus st as the second function. So 2a minus t into e power minus st divided by minus s, minus derivative of 2a minus t, that will be minus 1 into e power minus st divided by s square between the limits a and 2a. Now applying the limits, let's simplify this, we'll get applying upper limits and minus the lower limits. So I'll get f of s equal to, so this term no change in that, so 1 divided by 1 minus e power minus 2as times, applying upper limits to this, minus 1 by s times a into e power minus as, so a into e power minus as, minus applying lower limit 0 into e power 0, that will be 0, minus 1 by s square times, applying upper limit e power minus as, minus applying lower limit I get e power 0, that is 1, plus minus 1 by s times, so you will get minus 1, so minus 1 by s times, applying upper limit is 2a minus 2a into e power minus 2a, so that will be 0, minus applying the lower limit a, 2a minus a, that is a into e power minus as, a into e power minus as, minus into minus plus 1 by s square times, applying upper limit e power minus 2as, minus applying lower limit e power minus as. So these are the terms that I have obtained after applying the limits. Now simplifying this expression, so we get f of s equal to 1 divided by 1 minus e power minus 2as times minus a into e power minus as by s, 0, minus 1 by s square times e power minus as plus 1 by s square, minus into minus plus a into e power minus as divided by s plus 1 by s square into e power minus 2as minus e power minus as divided by s. Now these two terms are same with opposite signs, so these two get cancelled, so I will remain with f of s equal to 1 divided by 1 minus e power minus 2as times, so I will write positive terms first, so minus 1 by s square e power minus as, 1 by s square, again 1 by s square, I have s square common in the denominator, so s square will take outside, 1 minus these two terms are right, 1 minus 2 times e power minus as, the remaining one is plus e power minus 2as. So these are the terms within brackets. So I have f of s equal to this. Now I can compare this with, this has the coefficients of this form, 1 minus 2 1. So I can compare that with a square minus 2ab plus b square. If I compare, then a is 1, and b square is e power minus 2ax. So b square is e power minus 2ax. So taking square root on both sides. So b square whole power 1 by 2. 2 to get cancelled. It will be equal to e power minus 2as by 2. That is e power minus as. So I can write this one as 1 divided by s square times 1 minus e power minus 2as times. I can write this one as a minus b whole square. That is 1 minus e power minus as whole square. So comparing this with this expression, I can write this one as 1 minus e power minus as whole square. Now again compare this with a square minus b square. If you compare this with a square minus b square, again a is 1 and same argument, b is e power minus as. And we know that a square minus b square equal to a plus b into a minus b. You can write or I can use that relation here. So this will be f of s equal to 1 by a square times 1 divided by a plus b into a minus b. That is 1 minus e power minus as into 1 plus e power minus as times 1 minus e power minus as whole square. So 1 minus e power minus as, one term will cancel with this. So I will remain with 1 divided by a square times e power 1 minus e power minus as divided by 1 plus e power minus as. So that is f of s. Sometimes we will be asked to show that the Laplace transform of f of t equal to 1 by a square times tan hyperbolic of a is by 2. So in that case, we have to simplify it further. So how can we simplify it further? To see that, we have to recall some hyperbolic and exponential results. See, we have sin HAS equal to e power as minus e power minus as by 2. Tan HAS, before that, cos HAS equal to e power as plus e power minus as by 2. So what is tan HAS in terms of exponentials? That is nothing but sin HAS by cos HAS. So tan HAS will be e power as minus e power minus as divided by e power as plus e power minus as. And here you will be asked to prove in general 1 by, I have to prove that Laplace transform of f of t is 1 by a square into tan h of as by 2. So what should we do in that case? Actually tan h of as by 2 means that is e power as by 2 minus e power minus as by 2 divided by e power as by 2 plus e power minus as by 2. So I should get here e power as minus as by 2. So I'll multiply this by to get e power minus as by 2. Or let us don't worry about this one. Worry about this one. Here I have 1. I have e power as by 2 here. So I should get e power as by 2 here. So I'll multiply numerator by e power as by 2. And also in the denominator, I want e power as by 2 here. So divided by e power as by 2. So multiplying both numerator and denominator by e power as by 2, I'll get f of s equal to 1 by s square into e power as by 2 minus the product of these two will be e power minus as by 2 divided by e power as by 2 plus e power minus as by 2. So f of s equal to 1 by a square tan h of as by 2. That completes the solution of the second problem. There is a problem that is exactly similar to this. C or problem 3. This I have to try later. Find L of f of t. Find L of f of t if f of t equal to there's two values e and minus. E if 0 less than or equal to t less than or equal to a by 2 and a by 2 less than or equal to t less than or equal to a, and f of t plus a equal to f of t. Or you may ask to prove that, show that L of f of t equal to 1 by s into tan h of as by 4 if f of t is equal to, if f of t is this function. So you have to prove that L of f of t equal to 1 by s into tan h of as by 4. So the procedure is exactly same as this problem. As usual, write the formula, then substitute for capital T first, then substitute for integrand f of t, then simplify the expression by using integration by parts, then write the right hand term as a minus b whole square in that form, then use a square minus b square formula in the denominator, then cancel the terms, then multiply both numerator and denominator by e power as by 4. That reduces log f of t to this one. So this is the problem C. There is one more problem, the last one, and also the important one. As usual, find L of f of t if f of t equal to, find L of f of t, problem D. L of f of t, if f of t equal to e sin omega t if 0 less than t less than pi by omega and 0 if t greater than pi by omega, and f of t plus 2 pi by omega equal to f of t. Now we need to find the Laplace transform of this one. Solution. So as usual, write the formula to find the Laplace transform of a periodic function. So given f of t equal to e sin omega t 0 less than t less than pi by omega and 0 if t is greater than pi by omega, and here capital T is comparing this with f of x plus capital T equal to f of x, we get capital T equal to 2 pi by omega. Then by the formula Laplace transform of f of t equal to 1 divided by 1 minus e power minus s capital T into 0 to capital T e power minus st f of t dt. So that implies substituting for capital T, L of f of t equal to 1 divided by 1 minus e power capital T is 2 pi by omega s into integral 0 to 2 pi by omega e power minus st f of t dt. Here function is defined in two intervals. When t lies between 0 and pi by omega, it has some value, that is e sin omega t. When t is greater than pi by omega, it is 0, f of t is 0. So I don't worry about this interval. So directly I can write f of s equal to 1 divided by 1 minus e power minus 2 pi by omega into s integral 0 to pi by omega e power minus st e sin omega t dt. So So next interval it will be 0. Pi by omega to 2 pi by omega. So here integrand is 0, no need to worry about this part. This will be 0. Now I want to find the value of this integral. I have that integrand of the form e power minus st into sine. So I have to use that standard result. Standard result is what? Integral 0 to or without limits, right? Usually integral e power 8t sine bt dt equal to e power 8t divided by a square plus b square a sine bt minus b cos bt. This result we have to use. That is a standard one. Using that, we have f of s equal to 1 divided by 1 minus e power minus 2 pi s by omega into. So comparing this with this, I have in place of a minus s and in place of b omega. So e you can take outside, that is the constant term. Using that result, e power minus st divided by s square plus omega square, e power minus st divided by s square plus omega square times a sin bt, that is minus s sin omega t minus omega cos omega t between 0 and pi by omega. Now applying limits we get, so f of s equal to e by 1 minus e power minus 2 pi s by omega into 1 by s square plus omega square, that is constant, you can write it outside. Now applying upper limit, e power minus pi s by omega times minus s into, if I substitute for t here, omega omega get cancel, you get sin pi 0 minus again minus omega into cos omega t. If I substitute for t, omega omega get cancel, you get cos pi. Cos pi is minus 1 minus substituting the lower limit, you get e power 0, that is 1 into again 0, sin 0 gets 0 minus cos 0 get 1, so minus omega into 1. So this one I have e divided by s square plus omega square into 1 minus e power minus 2 pi s by omega times e power minus pi s by omega into minus plus 1 minus into minus plus omega. So I can take omega outside. So taking omega outside, I will get e omega times 1 plus e power minus pi s by omega divided by s square plus omega square. You can compare this term 1 minus e power minus 2 pi s by omega with a square minus b square. So I will get a equal to 1 and b square is e power minus 2 pi s by omega. So taking square root on both sides, I will get b equal to e power minus pi s by omega. So expanding this using a square minus b square formula, it will be a plus b, that is 1 plus e power minus pi s by omega into 1 minus e power minus pi s by omega. So 1 plus e power minus pi s by omega, 1 plus e power minus pi s by omega will cancel. So I will get f of s equal to e omega divided by s square plus omega square, e omega divided by s square plus omega square into 1 minus e power minus pi s by omega. That completes the solution of problem B. So this is about the Laplace transform of periodic function. So totally we have discussed 4 problems and all of them are most important. So study with this. If you have any doubt,